Good afternoon to everybody. If I just introduce myself, I'm Professor Catherine Godson. I'm the Secretary for Science in the Royal Irish Academy. And it's a great pleasure to welcome you from Dublin, from Germany, and from elsewhere. And thank you for joining us for the Kathleen Lonsdale Chemistry Prize 2021. This is the second year of holding the ceremony online, and although we wish we could be welcoming you to Academy House today, we are delighted to be welcoming you virtually for today's event, which I think we all understand the circumstances of the virtual welcome. So we warmly welcome our winner, Dr. Connor Crawford of the University College Dublin, along with his family, particularly his parents, Alison and Brian, his academic collaborators and his mentors. We're also joined by Dr. Hugh Fay of Henkel Ireland. Henkel's sponsorship of this award is vital in enabling us to recognise excellence in early career research in chemistry. The Academy is committed to supporting the highest standards of research and scholarship across the stages of the career spectrum, from early awards such as the Kathleen Lonsdale and the Hamilton Prizes to the Academy's gold medals. Since its inauguration in the year 2000, the Kathleen Lonsdale Royal Irish Academy Chemistry Prize has been judged by expert members of the Physical, Chemical and Mathematical Sciences Committee of the Academy. The judges select a winner based on the most outstanding PhD research in the general area of chemical sciences performed on the island of Ireland. As we'll hear from Professor Christine O'Connor, chair of our judging panel, the standard of applications from young men and women at the start of their careers in chemistry was exceptionally high this year. As recipient of the Academy Prize, Connor's award-winning essay, A Chemical Biology Approach to the Study of Cryptococcus neoformans, Developing Tools and Therapeutics, was also selected to represent Ireland in the prestigious International Union of Pure and Applied Chemistry Solvay International Award for Young Chemists competition. Through this prize, we've been able to recognise the impressive research of many promising doctoral students in chemistry over the past couple of decades. We'll now hear from last year's winner, Dr. Ikaiju, about what winning the prize meant for him.
Hi everyone, my name is Ikaiju. I am the recipient of the 2019 Kathleen Lonsdale Prize. I did my PhD research at Queen's University Belfast with Professor Stephen Bell. Right now, I'm working as a Lieberhume Early Career Fellow in the chemistry department at Queen's. So in a nutshell, my PhD research was about assembling nanoparticles into bulk materials while retaining their nano properties. But before we get into this, I'd like to talk a little bit more about nanoparticles first. So whenever materials shrink down to the nanoscale, their properties change dramatically. I mean, I'm talking about a world where metals melt easily, silver looks green, and carbon becomes fluorescent. And so naturally, many of us believe that within this nano realm lies the keys to technological advances that could truly revolutionize our lives. And indeed, nature has given us a glimpse of this with water striders, for example, or wall-walking geckos that all get their superpowers by sporting nanostructures. And because of this, a lot of effort has been devoted into finding ways to synthesize nanoparticles. And we now have a variety of nanoparticles covering the bulk of the periodic table. Now, with these nanoparticles at hand, the next step to actually applying them in real life is to assemble them back up into bulk structures so that we can actually handle them. And this brings us back to my PhD research. Because nanoparticles are so small and so difficult to directly manipulate, so the route that we've selected to go is to alter the environment around them so that the nanoparticles will want to assemble themselves into bulk structures. In practice, this is actually quite simple. It only requires shaking a water solution of nanoparticles with an immiscible oil and a tiny amount of chemicals. What we're looking at here is a silver nanoparticle array, but the same method works for all types of nanoparticles. So right now, my research team is focused on expanding the range of nanomaterials that we can assemble and also applying these assembled nanoparticles in spectroscopy and catalysis. I was and still am absolutely thrilled to have been selected for the Kathleen Lonsdale Prize. I still recall quite clearly the day that I learned about the prize at the start of my PhD, whenever it was still called the Young Chemist Prize, and secretly making it one of my PhD goals. That's why winning the prize was very fulfilling to me, a dream come true and a testament to my efforts, but also a reminder to me that hard work does pay off. Winning the prize has also been a huge confidence boost and a boost to my academic profile, which is why I will always be grateful towards the Royal Irish Academy and Henkel for sponsoring this prize.
So, thank you very much, Dr. Hugh. That was really very interesting. So, I'd now like to thank the expert panel for their commitment and expertise in what I think was a very difficult task of selecting a winner. The assessors were Dr. Katerina Nestorenko, Scientific Program Manager at SFI, Professor Peter Robinson, Chair of the Physical, Chemical and Mathematical Sciences Committee, and Professor of Chemical Engineering at Queen's University Belfast, Professor Sylvia Draper, Professor of Inorganic Chemistry and Head of the School of Chemistry at Trinity College Dublin, and Professor Christine O'Connor, Assistant Head of School of Food Science and Environmental Health at TU Dublin. So now I'd like to invite Professor O'Connor, Chair of the assessment panel, as we've heard, to say a few words about this year's competition and indeed about our winner, Connor Crawford. Thanks, Christine.
Thank you, Catherine. The standard of applications for the prize is always extremely high, and this year was no exception. The assessment panel, who you have seen are members of the Physical, Chemical and Mathematical Sciences Committee, read descriptions of some incredibly impressive research from across all of the institutes in the island of Ireland. I wanted to thank all of those who entered this competition and to congratulate you on the excellent research you are doing whilst in the midst of a global pandemic. I would also like to thank Henkel for their continued support of the prize, which is very much appreciated. We are here today to recognise the outstanding scientific achievements of our 2021 winner, Dr. Connor Crawford. Connor completed his PhD, a chemical biology approach to the study of Cryptococcus neoformans, developing tools and therapeutics in the School of Chemistry, UCD, under the supervision of Professor Stefan Oscarsson. Connor's research focused on therapeutic approaches to Cryptococcus neoformans, a major human pathogen responsible for approximately 600,000 deaths annually. Infection by the fungus is common and usually asymptomatic. However, if a patient's immune system becomes compromised, for example, through HIV infection, or is chemically suppressed for organ transplantation, the infection can re-emerge and is very difficult to treat. Current therapies are often unsuccessful in totally clearing the infection and are witnessing rising resistance. This PhD project has attempted to better understand Cryptococcus neoformans biology, particularly focusing on its glycan coat, termed a capsule, which is a critical virulence factor. Connor contributed to the successful synthesis of a library of 26 synthetic glycans up to an 18 mer in size. To do this, he performed convergent total synthesis over hundreds of steps using a wide variety of chemical reactions, including selective protecting group manipulations, chemoselective oxidations, and stereoselective glycosylations. He did encounter serious issues when he was doing a global deprotection of the glycans, but he developed new deprotection methodologies which could be performed under continuous flow and ultimately allowed access to the desired glycans in meaningful quantities and purity. Through synthetic organic chemistry, chemical biology, microbiology, and immunology, Connor has created vaccine candidates diagnostics, and tools that allow to gain a better understanding of Cryptococcus neoformans, its capsule, and antibodies directed towards its glycan coat. Ultimately, this research hopes to develop new therapies to advance human health. Conor has published his research findings in 7 high-impact peer-reviewed journals, in which he was first author on 5 of them. Conor's major achievements on completion of his PhD were the following: total synthesis of Cryptococcus neoformans capsule, printing and scanning glycan microarrays, and the construction of the first GXM microarray containing 26 synthetic structures. And this is allowing for rational vaccine design through understanding of antibody epitopes, and also allowing the study of antibody structure-function relationships. In relation to vaccines, Conor created conjugate vaccines bearing synthetic and native glycans, which are now taking part in mice testing and immunological assays. Conor has also developed chemical biology tools using hydroxylamine-armed fluorescent probes to inform knowledge of capsule architecture and biosynthesis, and he has also designed and synthesized FRET probes to identify and characterize antibodies catalytic against glycans. So I'm sure Conor will describe his own research much more effectively than I have just done. But just to note that the Kathleen Lonsdale assessment panel were very impressed with the excellence of your research, Conor, and your dissemination, and wish you every success in your future career. So I'll hand you back to Catherine. Thank you.
Thanks, Christine. Gosh, Conor, that was pretty impressive. That's for sure. So you're a very worthy winner of this award. So I'll now invite Dr. Hugh Fay, who's joining us on behalf of our sponsors, Henkel, as we heard before, to say a few words and, most importantly, to present this year's prize.
Good afternoon, everyone. It's a pity this is virtual, but I know the RIA run it very well, so it's a lovely event done well. The advantage is we get to see the mammy and daddy, I suppose, which is good. And we get to see the previous winners you can attend, which wouldn't normally happen. So that's good. This is the 5th year that Henkel Ireland has had the honour of sponsoring this great event. And honestly, it is really an honour for us. We're delighted to be associated with the Kathleen Lonsdale Prize, because here in Dublin, we have 100 people working in R&D. So research in Ireland and supporting young researchers is of particular relevance to us. I mentioned last year, and I'll say it again, I think it's important to note that this sponsorship has actually come from Henkel headquarters in Dusseldorf. There is a global fund for supporting meaningful social initiatives, which is termed Make an Impact on Tomorrow. So the fact that the corporate jury, who have global outlook, supports the Kathleen Lonsdale Prize is indicative, I think, of the esteem in which this event is held. Conor, having read a summary of your work, and I have to say, mentioning the word vaccines anyway could never be more appropriate, it's clear that you are a most worthy winner. So all that remains for me to do is to congratulate you and to virtually present you with your award, which I know you have there. So I will say, Dr. Connor Crawford, I present you with the Kathleen Lonsdale Royal Irish Academy Chemistry Prize for 2021. Congratulations.
Thanks very much. I don't actually have it with me because I couldn't bring it on the train because I thought it looked a little bit weird, but I have a photo of it that I can share when I give a presentation. But thank you very much, Hugh, for the kind words.
You're welcome.
So hello, everyone, and good afternoon. Thanks for joining to celebrate me winning the Royal Irish Academy Prize named after Kathleen Lonsdale. Let me just say, really tremendous honor. And when I got the news, I was really humbled. Hopefully, by being selected, it will stand to me in the future and maybe open doors that otherwise could not have been opened. One thing from a personal standpoint that I really like about the Royal Irish Academy in particular is that you have the humanities and the sciences under one roof, so to speak, even though we're not here today. Because I think this is going to be extremely important in the future for the big challenges humanity is facing. And I think interdisciplinarity and big thinking is what's required to tackle the biggest threats facing humanity, such as climate change or infectious disease. But first, I'll give you a little biography of me. My name's Connor. I'm 26 years old, and here you can see a little picture of me here. I'm from Ireland, of course, as you could guess, probably by my accent. And then in particular, I would say I'm a man of the Pale. Although we don't use that word anymore, I would still use it myself. And that means that I hail from the greater Dublin area of Wicklow, Kildare, Meath, Dublin. And in particular, I went to school in Meath. But I must admit, I'm not entirely a man of the Pale. All of my wider family are from Belfast, and in particular, everyone. In particular, my parents are from inner city Belfast, and they grew up during the height of the Troubles. And this was during the civil rights movement in the North for Catholics to have equal rights and equal representation in the state that is the North of Ireland. And I think what was instilled in me as a child was the importance of education and how this is an upward mobilizer. And I think that's why I'm a big nerd. Then briefly, I studied my Bachelor's of Science in University College Dublin, doing a degree called Medicinal Chemistry and Chemical Biology. And this degree was formed and started by Stefan Oscarsson, who went on to actually become my PhD professor. And I think the great thing about this course is that it spans across the College of Science, and particularly in the biological and chemical space. And this is, I think, pretty unique, especially in the Dublin area. I liked my degree so much, I decided to stay. And in particular, I asked Stefan, could I have a shot in his lab to do some research? And his research focus could be broadly described as the chemistry and biology of sugars. And this is also what I'm interested in. But before I give a little brief overview of the science, even though it's been covered, first, what I think is obvious to me and should always be stated out loud is that I have had access to excellent mentors throughout my career. And I'll just start chronologically. So first is Paul Evans here. He's an associate professor at UCD. And in the summer of 2015, he gave me my first shot of a chemistry lab outside a formalized setting. And he let me work on this molecule here called saccharin. And you could, for those of you that don't know, saccharin is an artificial sweetener. And you could say that this was the start of a sweet journey in science. So then I had so much fun. I continued with my degree, of course. And then I ended up doing my BSc final year project in Stefan's lab, working with a sugar called sialic acid. And I found this really interesting and fun. So one day I knocked on Stefan's door. I said, can I please do a PhD in your lab? And let's discuss some projects. We were talking about projects, and Stefan said there was a possibility of a project in vaccines and synthetic vaccines. And this really captured my imagination because it had a nice mix. But I remember him saying to me, I don't know, maybe I need a postdoc to do it. I'm not sure. But basically, I nagged him a little bit, and I think he gave in, and hopefully he doesn't regret it. And then really what I did in Stefan's lab was focus more on real sugars. And to do this and fund this research, I applied for an Irish Research Council postgraduate award, and I was lucky enough to get it. And then this basically allowed me to, for 4 years, do science in UCD. And then in my third year, I had created quite a lot of tools and vaccines and therapeutics. And I asked Stefan, could I go to Arturo's lab to go get to test them? Arturo Casaval is a professor and chair of molecular microbiology and immunology in the Johns Hopkins School of Public Health in Baltimore, Maryland. And Arturo is a really open guy and said, of course, a chemist can come to a microbiology and immunology lab. Why wouldn't he? He gets to use the tools he makes. And I had a wonderful time. And I think it was really transformative for me. And basically, Arturo is very famous for working with these things called antibodies, which we're all experts in now. You can't go out without people talking about their antibodies these days. And really, the antibodies we were interested in were antibodies that recognize sugars. And I had such a great time over all these years that I decided I really liked science and I wanted to stay in an academic research environment. And I was thinking of where could I go? And then I sent an email to Peter one day and I said, could you please consider me as a postdoc in your lab? And Peter replied, yes. And that's where I am now to this day. And just a little word about Peter. Peter is a professor and director here at the Max Planck Institute for Colloids and Interfaces. And Peter is famous also for sugars, but more specifically for making these machines that expedite the synthesis of sugars once you develop automated processes. And the reason I wanted to learn how to do this was because when I was in Stefan's lab, Sometimes there's a little bit of repetition in carbohydrate chemistry. As the speaker, when they introduced me, noted that there's lots of steps. But if you could figure out an automated process to make this a little bit faster, this would be highly attractive for me, because it frees up my hands and frees up your imagination to think about maybe something a little bit more entertaining. But then what did I do during my PhD, to go backwards, was I studied this fungi here, Cryptococcus neoformans. And here's a picture of the cells. You see the cells are these little circles, but you'll notice that these cells have a little halo here. And this halo is their capsule. And this is a sugar coat. That was what was our interest of study. And why would you want to study Cryptococcus neoformans? As it has been introduced, it's basically found throughout the environment, infects lots of people in childhood. Many of us were probably infected but didn't notice. But if you become immunocompromised, this fungi is a big threat to your life and your health. So with the number of immunocompromised people growing globally, and also rising resistance to antifungal drugs, much like the rising resistance of antibacterial or bacteria to antibiotics, creating vaccines and understanding this critical virulence factor is of real importance to humanity. So how did a chemist do this? What we do is we synthesize sugars in Stefan's lab, and then from this, we're able to create molecular tools that allow us to interrogate and understand C. neoformans biology. And the thing to point out is, without chemical synthesis, these structures are otherwise unobtainable, and that's why chemists are in a unique position to exploit and make these kind of things and understand biology. So our goal was to understand the sugar coat and the antibodies to recognize this, and then through this create rational vaccines. I can say that we had some success. We synthesized a lot of oligosaccharides, we made new chemical tools, and we created 5 vaccine candidates, all of which are currently under investigation in Johns Hopkins in Arturo's lab. And these vaccines use the same platform technology that's called conjugate vaccines. And it's the several successful products and companies use this, like GSK and Pfizer. And it's a common vaccine used in children's immunizations in Ireland. Since it is the Kathleen Lonsdale Prize, I thought I'd just mention this molecule here, which is a benzyl ether. But Kathleen, for those of you that don't know, is very famous for resolving the structure of benzene. And I also had my fun with benzene, so I thought I would include it. And the reason is that carbohydrate chemists protect a lot of sugar hydroxyl groups with these ethers. But when I was removing them, I had a terrible tired time, and I was getting this happening to my benzene ring. And I think if Kathleen was here, she obviously isn't, would have enjoyed talking about this science maybe afterwards. But then more critically, once we were able to assemble well-defined synthetic glycans, we could then print them on these glass surfaces called array, and they create things called arrays. And then we can pour antibodies onto these arrays and use fluorescence-based techniques to see what the antibodies like in structures. And from this, we can use this to rationally design and incorporate these structures into vaccines. So then I attach these sugars to proteins, and this creates the vaccine. And the reason you do this is because making the sugar-protein connection allows antibodies and a long-lasting specific immune response against these structures. Then I got to go to Baltimore and left Dublin for a little time and got to take part in the animal immunization protocol. And this meant I got to inject the very vaccine I had created in Dublin into mice in Baltimore, monitor their immune response. And we do this by studying the antibodies that form in their blood. And then we also do functional characterization, and we see that the antibodies have the signs that they could protect the mouse from a challenge experiment. And to date, this is where we are at now. We're really excited, and we're just nailing down the fine details. And hopefully one of our 5 candidates meets the criteria that we could then start thinking about preclinical human trials, which is really exciting. And then just to say, this is when I became a real scientist to my mother and my father and my neighbors, is when I was talked about this research on RT and a science show called 10 Things to Know About. And it's presented by this really great academic in UCD called Avi Nushulavon, and she's a professor of mathematics in University College Dublin. So that was really fun. Then just one last slide before I give the acknowledgements is what am I working on now? So my sweet journey has continued, so to speak, but no longer in the context of infectious disease, but now with the focus of the carbon cycle and the Earth's kind of steps and needs to establish a green circular economy. So while many of us are comfortable and would be well aware of the idea that plants turn CO2 into sugar, and this sinks carbon, and this is important for the Earth's climate regulation, what is commonly overlooked and was only beginning to be understood, and we just don't have understanding on the molecular level, is that half of this actually CO2 fixation takes place by photosynthetic phytoplankton. And this is half of the Earth. So it's like all of the rainforests and all of these trees, half of this is taking place in the ocean. And this is one of the fastest catabolic, metabolic cycles of life on Earth. And it's fueled by these kind of an interplay between photosynthetic plankton and bacteria. And basically what I'm doing at the Max Planck here now is creating new molecular tools that we can understand this process. And this is just a little picture of the people I get to work with. It's Peter again, and he's the director at the Max Planck Institute for Colloids and Interfaces. And then the plan is, once I synthesize enough tools and new things to study with, I get to go over to the Institute for Marine Microbiology in Bremen and work with these two excellent scientists here, Jan Herman and Rudolf Alman. And then we applied for a grant to the European Commission, and luckily I got it. And so now I'm about to start my fellowship with Marie Curie in the coming weeks. And then finally, it would be obviously remiss of me not to mention all the excellent people I got to work with throughout my time, mostly in Dublin and a little bit in Baltimore. In particular in the lab in Dublin, Thomas, Dennis, Clotilda, and Martin, all really great people. But then in particular, Abdullah and Mark, who were my fellow PhD candidates, and we had a really great time together. I think, as is often the case in a chemistry lab, you spend more time with these people than you do with your real family. So it's great that I had this time to share with so many nice people. And then also the people in Johns Hopkins that were so open-minded and taught a chemist a lot of cool microbiology and immunology techniques. Then, thanks to the funding bodies, Science Foundation Ireland, who heavily funded Stefan's lab over the past few years. And it basically allowed me to buy lots of fancy, cool reagents to get to play with. And then the Irish Research Council, which helped fund my trip to Baltimore and also go to conferences and things like this and see great science. The two institutes, University College Dublin, Johns Hopkins, for providing the space for this kind of research. And then last but definitely not least, thanks to the Royal Irish Academy for this year's Kathleen Lonsdale Chemistry Prize. It was a tremendous honor.
Congratulations again, Connor. I think we'll all agree a most worthy and indeed a most gracious winner. And congratulations also to his academic mentors, to Professor Oscarson, Professor Seeberger, Professor Gyrey, Gilheeney, and of course, all of their colleagues. And thanks to all who've made this event possible, the ambitious scholars, their supervisors and mentors, and the schools and the chemistry schools and departments around Ireland who encourage them to aim for this prize and support them in all their academic endeavours. Thanks again to the judging panel, and of course to our sponsors, Henkel, and to Dr. Fay for being here today. So we're going to leave you today with the story of one of Ireland's greatest chemists, Kathleen Lonsdale, as told by historian and author Dr. Linda Lunny.
My name is Linda Lunny. Until I retired 18 months ago, I worked in the Dictionary of Irish Biography, which is a project of the Royal Irish Academy. Kathleen Lonsdale got one of the over 9,000 biographies that we wrote for that publication. Along with a colleague, Enda Lini, I worked on her life. Why should we remember Kathleen Lonsdale? Why is this prize named in her honour? And why, more generally, should we remember her in Ireland? She hadn't the best start in life, at least to outward appearances. She was born in 1903, the youngest of 10 children, in Newbridge, County Kildare. Her father was an Englishman who was the town postmaster, but he had a drink problem. And when Kathleen was only a small girl, her mother separated from her father and took her family of 10 children to England. 4 of the children died in infancy, but Kathleen made a great success of her education. She got the top county scholarship to go to high school, and when she was 16, she was able to go to attend Bedford College for Women in London. The Nobel Prize-winning crystallographer W.H. Bragg was the external examiner on Kathleen's outstanding final degree exams, and he was so impressed by the diminutive and very determined young woman that there and then he asked her to join his group in University College London to study the crystals of organic compounds. She developed novel techniques and insights, and she was able to confirm the structure of the benzene ring, which was something that had puzzled scientists, including Bragg, for more than 60 years. Another major contribution was her compilation of essential reference tables for X-ray crystallography. So, we should remember Lonsdale for more than her contributions to chemistry, acknowledging her importance as a role model for women. And she was someone who made practical recommendations on the changes to society that would make it possible for more women to work in science and industry. And still, that isn't all. In 1935, she and her unusually supportive husband, Thomas Lonsdale, became members of the Society of Friends, and as Quakers, they opposed war. But Kathleen Lonsdale refused to register for war work, and thus was sentenced to a month in Holloway Prison. Her experiences of the dire conditions led her to become a campaigner for prison reform. Later, she also became internationally known as a leader in movements opposing nuclear testing and armaments. And to finish with, something to think about, a quotation from Lonsdale herself, which is at least as relevant today to young and to old scientists, at least as relevant as it was in the 1950s. I believe in good, not just as a hypothesis, but as absolutely fundamental to all my way of life. A scientist should take interest in national and international affairs, not as a politician, but in making sure that facts are properly known and trying to ensure that science is used for good and not for evil purposes.
Thank you. That was really inspiring. And I suppose over the past 15 or 16 months, we've become even more aware of the importance of science and the importance of scientific truth. So can I just thank everybody again for joining us and congratulate Connor again and wish you all well. And it's unfortunate that we're not enjoying the lavish hospitality of the Academy, but no doubt we will another day. So thank you very much.